This is a recording for the paper 6 OCR higher calculator paper in the series June 2024. Question 1. Below are 6 graphs ordered numbered 1 to 6 that show different relationships between x and y. For each description below, write down the number of the graph that best represents the relationship between x and y. X is the temperature in, so I'm going to look at this one first. X, temperature in degrees C, Y, temperature in degrees F, where Y is equal to 1.86 plus 32. I can see this is a linear graph, straight line graph, so that's either graph 1, 2 or 3. This has a positive gradient, so I know it's sloping uphill, so it's graph 1 or 2. And I know it won't start at 0 because it's 1.8x plus 32. If x is 0, it's going to start at 32, so it's got to be graph 2. Okay, for part B. Average speed when running 200 metres on the x-axis. Time taken to run 200 metres on the y-axis. Now I know as the speed increases, the time taken to run the 200 metre will decrease. So we're looking at graph 3 and graph 5. I also know that speed is equal to distance over time. So the distance is staying as it is. You can see it's like an inverse proportionality relationship. So it's graph 5. And then this bottom one, C, X is the mass of a solid object made from clay. Y is the volume of the same solid object. So as X increases, Y would increase. And it would have to start at 0. It'd be a linear relationship, so it's graph 1. Question 2, the graph shows a household's average daily electricity usage in kilowatts per hour. You have 2 reasons why this graph is misleading. I can see straight away there are no values on the vertical axis. That's one of your reasons. Right, let me look at the x-axis in more detail. Right, can you see the scale is inconsistent on the x-axis? It goes from 2021 to 2022, and then January 2023. So inconsistent. Horizontal axis. Question 3, the word mathematics is spelled using tiles. The tiles put into an empty bag. One at a time, 99 children each take a tile at random from the bag. They recall the letter and put the tile back in the bag. Work out how many times the letter M is expected to be taken from the bag. How many M's are there? We've got 2 out of 11. So the probability of taking out an M is 2 out of 11. We've got 99 children. Times 9. Times 9. 18. So 2 over 11 is the same as 18 over 99. So 18 times. 1 centimetre on a map represents 150 kilometres in real life. Below is part of the map showing city A to city B. Heidi is planning to walk from city A to city B for charity. Heidi measures the straight line distance on the map from city A to city B is accurately 5 centimetres. So if 1 centimetre is 150 kilometres, 5 times 150 kilometres by 5, I can work out what 5 centimetres is before I read the rest of the question. 750 kilometres. They are walking 750 kilometres from city A to city B. Heidi says she will walk from city A to city B at an average speed of 2.5 kilometres per hour for 10 hours per day. Use this information to work out how many days Heidi needs to complete the walk from city A to city B. Okay, this can be done in a variety of different ways. I'm going to be thinking if we walk 2.5 kilometres per hour for 10 hours, if I do 10 times 2.5, it's 2.5 kilometres per hour, you get 25 kilometres for one day. Got 750 kilometres to cover. 750 divided by 25, 30. So we've got 30 days. Explain why the information used in part 1 is likely to give an underestimate of the number of days Heidi needs to complete the walk. It's not going to be a complete straight line, city A to city B. Yeah, that's enough. Yoshi writes the scale of a map. 1 centimetres represents 150 kilometres as the ratio 1 to 150. Now, on a map, that ratio is centimetres to centimetre. 1 centimetre represents 150 centimetres. The scale given as a ratio on a map is always centimetre to centimetre, so that's Yoshi's error. Has not converted to centimetres. And then we need to answer this correctly. So 150 kilometres. We need to convert that into centimetres. 1 kilometre is 1,000 metres, so times by 1,000. So you've got 150,000 metres. We need to times it by 100 to convert into centimetres. So we have 15 million. Diagram shows a regular pentagon made using 10 congruent right angle triangles. So congruent means they're exactly the same size. The length of one side of the pentagon is 12 centimetres. Show that the area of the pentagon is 247.75 centimetres squared. Correct 2 decimal places. Now I know to find the area of a triangle is base times height divided by 2. I'm going to take out one of these triangles. It looks like we don't have much information to go on. We know the base is 6 centimetres. That's half of the 12. Right, we don't have much other information here, so we need to think, can I work out any other missing lengths or any of the angles using the properties of the shape? Because if I can get another length, I can use Pythagoras, or if I can get an angle, I can use SOHCAHTOA. Now I'm just zoning in here. Angles around a point at 360. There are 10 congruent triangles, so 360 divided by 10 is 36. This angle here must be 36. To find the area of a triangle, it's base times height divided by 2, so I need to know the height. I've got opposite, I've got adjacent, so I know it's tan. Tan 36 equals O over A. O is 6, A is X, times both sides by X. Divide both sides by tan 36. Six divided by tan 36 is 8.258. And times that by 10. not going to times that by 10. So I was thinking if I times that by 10, I do not get that answer. That's just my missing length, isn't it? Right, so now I know base times height divided by 2 gives me the area of the triangle. So height times base divided by 2. And then times that by 10, because there are 10 congruent triangles, all with the same area, which gives me an answer of 247.75 to 2 decimal places. So I have shown the area of the pentagon is 247.75. The regular pentagon is the base of a pyramid. The pyramid has a volume 450 centimetres cubed. The perpendicular height of the pyramid is h centimetres. Calculate h. So we're actually given the volume of a pyramid, so we know a third times the area of base, which we've just worked out, times height, which we don't know, I'm going to call that h. We know it's equal to 450. A few different ways you could rearrange this. I'm just going to actually work this out first. So 247.75 times a third, which is the same as dividing by 3, gives me 82.583 recurring, times h is 450. Now to get h, I'm going to need to divide both sides by 82.583 recurring. Which gives us a h of 5.4 to 1 decimal place. Okay, we have two numbers, a and b, are written as the product of prime factors. Find the lowest common multiple of a and b. Okay, now using prime factors, the highest common factor is anything that occurs in both. I'm just going to write out a in full, just because it'll help me show you how I get my numbers. Okay, what occurs in both here? 2, 7. If I look, there's nothing else that occurs in both. So the highest common factor is 14. The LCM is the highest common factor times all the extras. Highest common factor is 14. What do I mean by all the extras? 3, 7, 2 and 2. Let's just use our calculator. So 14 times 3 times 7 times 2 times 2 is 1,176. The number r is written as the product of its prime factors. R equals 2 times 3 squared times 5 times k, where k is a prime number. Highest common factor HCF of r and another number p is 26. So I'm going to write p as a product of its prime factors. Oh, they're both prime, so it's just 2 times 13. So in the last example, we looked at the HCF. Oh, sorry. Well, the P isn't 26, but it's useful to find the 26 in prime factors anyway, because as we discussed earlier, the highest common factor of two numbers are any factors that occur in both. So seeing as 26 is equal to 2 times 13, we've already got 2 in R, so you can see K is going to have to be 13, because we know 13 occurs in both. 2 bags of fruit contain only apples and bananas. In bag X, the ratio of apples to bananas was 5 to 7. In bag Y, 5/12 of the fruit are apples. So in bag X, you can see the total amount of fruit, well, as a proportion really, is 12, because 5 and 7 is 12. So what fraction in its simplest form are apples? It would be 5 out of 12. But that's just the proportion of apples. It could be 10 over 24. But as you can see, the proportion of apples in each bag could be, well, are the same. So Finley might be correct or he might not be. Because again, for bag Y, we know 5/12 of the fruit are apples, but it could be 10 apples and 24 altogether, which would simplify to 5/12. So show how we decided. Well, I've just written my ratio as a fraction. And this gives proportion. It's not the amount of fruit, is it? So we could be correct or we might not be. There might be that there are 5 apples and 7 bananas, 5 apples, 12 in total. Finley adds 4 apples to bag X. The ratio of apples to bananas is now 11 to 14. How many bananas are in bag X? Right, so the simplified ratio is 11 to 14. So if I took 4 apples off here, we would have 7 to 14, which doesn't simplify to 5 to 7. So it's not 11 apples in bag X. So we're going to continue and look at this ratio, looking at like multiples of this ratio. So if I times them both by 2, I get 22 apples, 28 bananas, which would simplify to 11 to 14. But I've added 4 apples. Let me take 4 apples off of here, which will give you 18 to 28, which simplifies to 9 to 14ths, 9 to 14, which isn't 5 to 7, so it's not that one either. Times your 11 by 3 to get 33, times the 14 by 3 to get 42. Again, I've added 4 apples, let me take them off, which gives you 29 to 42, which I know isn't going to simplify to 5 to 7. Times the 11 by 4 and the 14 by 4, which gives us 44 to 56. I've added 4 apples, let me take them out. Let's see what this simplifies to. 40 to 56. If I divide them both by 8, it gives me 5 to 7, which is my original ratio of apples to bananas. So can you see if I had 40 apples, 56 bananas, and I added 4 apples, I would have this ratio, which would simplify to the 11 to 14. So how many bananas are in bag X? 56. Complete this table for y equals x cubed minus 3x squared. So I'm going to substitute 3 for my x. 3 cubed minus 3 times 3 squared. You can just type that in your calculator. 3 to the power 3 minus 3 times 3 squared is 0. Right, you've got to be careful with negative numbers. So I would advise you to check you can do it correctly for minus 2 to give you an answer of minus 20. What you have to remember here, you don't really need brackets around the minus 1 cubed, but I'm going to put them in anyway, just to get in the good habit. Here, you definitely need brackets around the minus 1 before you square it. Otherwise, your calculator will not give you the correct answer. So minus 1 power 3 minus 3 times bracket minus 1 bracket squared gives you negative 4. Draw the graph. minus 2, negative 20, minus 1, negative 4. So it's kind of there. So negative 1, negative 4, 0, 0, 1, negative 2. 2, negative 4, 3, 0, 4, 16. It's a cubic graph. Well, I haven't drawn this the best. It's not easy to draw on my writing pad, but something along those lines. Use your graph to solve the equation x cubed minus 3x squared is equal to 5. So I need to know when the answer is 5, so I'm going to draw a line at y equals 5. Give your answer to one decimal place, 3.5. Sketch shows the coordinate axes and the point 0, 10. The distance from the point 0, 10 to a point 12 t, 12.5 units. So we just sketch this on the graph. So we'll cross 12 up t, we'll say is there. Although it could be here, but we'll allow for that after. Think about that after. Work out the two possible values of t. You must show your working and you may use the sketch to help. Hopefully you've spotted this right angle triangle here. So I know this is across 0 and this is across 12 because the coordinates of this point are 12t. I also know that the actual length of the line, the distance between the 2 points, is 12.5. So can you see I can use Pythagoras to work out the missing length. Sorry, this should not have the x squared bit there. So we've worked out that x, this missing distance here is 3.5. Now we know we could have, well, we know that this is kind of up 10 here. So 10 add 3.5 is 13.5. So that's one of your possible values for t. Now to consider the other one, well, it could have been a right angle triangle here. So that distance is 3.5. But we know the distance there is 10. So 10 minus 3.5 could give you the other value, which is 6.5. Y is inversely proportional to x cubed. Y equals 4 when x is 12. Find a formula linking x and y. Y is inversely proportional to x cubed. y equals k over x cubed. Let's sub in these values to work out k, our constant of proportionality. Times both sides by k cubed. Sorry, times both sides by 12 cubed. K is 6,912. So I'm going to replace my K for 6,912 because that never changes. X and Y do. So here's my formula linking X and Y. Write this expression in the form kx to the power m. Okay, so I'm just going to look at it all and think, well, how can I write things differently? I can write root x as x to the power half. Now I can multiply the numerator to simplify. 9 times 2 is 18. I can add the powers. 7 plus a half is 7.5. I think I prefer to see that. No, I can leave it like that for now. I usually prefer to use an improper fraction. Let's just leave it. Okay, I'm going to divide. I need to subtract the powers. 18 divided by 3 is 6. And now I need to do 7.5 minus 4. Because when the base is the same, we subtract the powers, which is 3.5, 3.5, or 7 over 2. M is 3.5, X is 6. Without using a calculator, show that 0.18 recurring can be written as 2/11. It's just a standard way for doing this. I'm going to multiply it by 100 because it's like double repeating digits. Line it up, everything is underneath each other. We can see where it cancels. Subtract 100x minus 1x is 99x. I subtract here, all of these disappear. I'm left with 18. Divide both sides by 99. It's going to simplify it on your calculator. 18 over 99 simplifies to 2/11. Explain how 2/11 equals 0.18 recurring can be used to find 10/11 as a decimal and write down its value. Okay, I know 2/11 times 5 is 10/11. I just need to times this by 5. So if you've got 0.181818 times 5, just do that on a calculator paper. I get 0.9090, so it's going to be recurring like 0.90 like this. Okay, we've got non-right angled triangles, working out a missing length AD. So I know it's going to be sine rule, cosine rule. Now, I can see already there's not enough information in my triangle ADC. I'm going to use the triangle ABC to get the shared length. So I can see I've got opposites, all that y. So I know it's a sine rule. A over sine A equals B over sine B. So 8 over sine 20 times sine 60, y equals 20.2567. So now, don't only have one pair of opposites, so I know it's cosine rule. Let me draw out this triangle separately. And also, I didn't use the labelling for the first one, so let me just explain. For the first triangle, I like to use my own letters. Oh, I did use b over sine b. I suppose I didn't use a over sine a, but let me just show you how I got all the values if you're confused. So I decided to call that big B, little b, big A, little a. You can see I've got a over sine a equals b over sine b. Anyway, that's our answer for y. Let's just draw out this second triangle. $55, 20.2567, 6x. So as discussed, we only have one pair of opposites. So I know it's cosine rule. So x squared, 6 squared plus 20.257 squared minus 2 times 6 times 20.2567 times cos 55. I'm going to type that all into the calculator. Square root both sides. X is, AD is 17.5. The diagram shows a circle with centre 0, 0 and a tangent at 12 minus 5. The tangent at 12 minus 5 crosses the x-axis at P0. Find the exact value of P. This is the radius of our circle. Also, knowing from our circle theorems that when you get a tangent touching a radius, we've got 90 degrees here. We know that this tangent is perpendicular to the radius. I can find the gradient of this radius. I know that 0.00. Gradient formula is y2 minus y1 over x2 minus x1. x1, y1, x2, y2. We've got minus 5 minus 0 over 12 minus 0. Minus 5/12. Okay, so the gradient of the perpendicular is a negative reciprocal of minus 5/12. Minus 1 divided by negative 5/12 will give you 12/5. Now I know the gradient of this tangent is 12/5. So P here I know one of the coordinates because it's on the x-axis. The y value is 0. We'll call the other one u for now for the x value. So I know the coordinate here. coordinate here is unknown. So we'll call it x1, y1, x2, y2. I know 0 minus 5 over u minus 12 is equal to this gradient of the tangent, 12/5. We simplify. I'm going to cross multiply here, so multiply both sides by 5. I'll just bring it up to the side here, gives you 25, and multiply both sides by u minus 12. Expand your brackets. Add 144 to both sides. Divide both sides by 12. So our value for u is 169 over 12. If you've written it as a decimal, it's 14.083 recurring. We could have it as a mixed number fraction. Any of those answers correct. Okay, last question. Write as a single fraction in its simplest form. So first of all, I'm going to put your 4 over 1 to make it a fraction. With algebraic fractions, I suggest factorise where you can first. If you see this numerator here, hopefully you've noticed it's the difference of 2 squares. So you can factorise it. I'm putting the denominator around wrong, because I had himself there. So difference of 2 squares, it would be x plus 7, x minus 7. Cancel. Now we can add. Let's get the denominator the same by multiplying the denominators. 1 times x minus 3 is just x minus 3. So I need to multiply the 4 by x minus 3. And I need to multiply the x minus 7 by 1. Expand your brackets. Simplify. Final answer. Okay, so we're at the end of this paper. Hopefully you found it useful. If you want to have a look, there's the 2023 series also on the YouTube channel. That may be worth you looking at. Okay, thank you.